So when you create an empty file, how much disk space does it occupy? You might say 0. But if it were 0, then how does the computer remember its name or where the file is? Well, it clearly is not 0. Also, what happens when you delete a file? Where does it go? What actually is a computer file? Let's start from the beginning. Approximately 13.8 billion years ago, the universe started. Now fast forward to 2026, we have computers, and we are using computer files to store data. So think of a computer file as some data that is classified with a name. Whenever you need to store data for a long time, even after rebooting and powering off, you have to store it on a disk. Now, check this. This is the shit that our computer understands, and we can save it on disk. But what is this? I don't understand shit. We can give it meaning. Let's say I made software where the user can switch between dark and light mode. Now I want to store the user's decision so that the user doesn't have to manually switch every time. Now, let's assume this means the user wants dark mode, or this means light mode. Now, I can write this to the user's disk with a name. And when the user opens the software, I will just read that data through the name. And if I find that the data is this, I will show dark mode. Or if this, then light mode. Well, believe it or not, this is actually how files work at their core. A creator stores some data on a disk with a name. The data doesn't have to be meaningful to everyone. But to make it meaningful, the creator will provide a set of rules that give meaning to the stored data. Different creators can give different rules that will have different meanings for the same data. For example, someone can create their own file with this data, which was our dark mode. But according to their rule, it is the letter A. Now, the different types of rules are known as file formats, like JPEG, PNG, or text. If you create a text file, it will store zeros and ones at the end of the day, similar to an image file. But the text file's creator and the image file's creator provide different rules to interpret them. And a text editor or a photo viewer will provide a different meaning for both files, even though both are built with the same zeros and ones. Please allow me to yap a little bit about files. So you can't just randomly start storing data on a disk like a psychopath, because other people, or at least other programs, are probably storing their stuff on the disk. Also, a disk is a physical thing. It has physical slots to store data, and you can't just randomly select a slot of your own, because someone else has probably already taken that slot. If you store data in that slot, you are just destroying their data. To manage all of this, we need a manager, and the manager is a file system. There are different types of file systems you can choose. You can choose the file system for a disk or a partition of a disk while formatting it. I'm not going into depth about how different file systems work. Instead, I'll explain how almost all file systems let you access a file and how much data there is when the file is empty. Now, how much data is there when the file is empty? You see, when you create a file, it stores some metadata. Metadata is essential data that is needed to manage the file, like accessing, editing, or deleting it. The metadata includes when it was created, by whom, the permissions of the file, and more. In Linux, the metadata typically ranges from 128 bytes to 512 bytes. In Windows, it is typically around 1 kilobyte. You might say you can get rid of the metadata to save storage. Well, if you think that, let me tell you about the most important metadata. And that will answer what happens when we delete a file. When we create a file, we probably think that the file is stored inside a folder. To your surprise, you probably have the wrong idea about a folder. You see, a folder is just a regular file. Yes, your whole life was a lie. A folder is just a file whose job is to organize all the files that are assigned to it. Allow me to explain. You see, when you create a file, all the metadata is stored in a special type of database, which is inside the disk and is managed by the file system. This database is known as the inode table. There are different names in different operating systems, but the idea is the same. One of the important pieces of metadata in the inode table is a unique identifier, which is simply known as an inode. Another one is the physical location of the file on the disk. Some people call it the pointer. The inode is used to find the file and other metadata of the file, and the physical pointer is used to find the data of the file on the disk. Now, when you create a file inside a folder, the folder will keep track of the file name and the associated inode. As I said, a folder is just a regular file. A folder keeps track of all files and folders inside that folder file. Don't forget that a folder is just a regular file. Now, the inode table keeps track of where the file is on the disk. It also tracks how many folders are pointing to the inode. And yes, multiple folders can link to one inode, which I will show you shortly. Now, when you delete a file in a folder, the folder first removes the link, and the inode table decreases the link count by 1. When the link count reaches 0, the inode table marks that physical space, the slots, as free, and other files can then use that slot. To understand it, let's do it practically. I'm on a Linux machine, and inside /home/pc/test folder, we have two subfolders, A and B. Now, let's create a file inside a folder using the touch command. We can use the stat command to see the information about the file. From here, we can see the inode number and the link count. See, the link count is 1. We can make another link to the file by using the ln command like this. Now, if we stat it again, we will see the link count is 2, and both files have the same inode. Now we will use the echo command to insert some text inside the first file. We can use the cat command to read the text. Now, when we read the second file, we see that it has the same data inside it. This is because they are literally the same file. Now, let's delete the first original file. That the link count has decreased to 1, and we can still read the second file. Only after deleting the second file will the link count decrease to 0, and the inode will be deleted, and the space where the file was stored will be marked as free. However, the file data is not wiped out from existence. It is still there, but no one is pointing to it. The file can still be recovered unless some other file replaces its data. Then it will be truly gone. We can connect it to our existence. When does our existence end? When we die, or when someone else replaces us? People link their thoughts to us. We can capture some time in other people's minds, which might remain after our death for a short time for most of us, and for a relatively long time for a few people. If you think you're like an inode, you should build as many links as possible, whether it is by building connections with people or by doing something meaningful. Remember, your inode will be replaced by other data if your link count reaches 0.